So you might ask, how can we know something like how deep or how hot a rock was millions of years ago? And the key to understanding the history of a rock is locked up in the minerals that make it up. And so this is a sample of one of the most useful rock types that we've found in Angel Lake Cirque and throughout a lot of the Ruby Mountains. This is a garnet amphibolite, and that means a rock made mostly of the mineral hornblende and garnet. And in this case, it also has a lot of this white mineral called plagioclase. And you can see the plagioclase is making white streaks in the rock. And in the core of those streaks, sometimes you'll see a little dark relic bit of the garnet that the plagioclase was replacing. Now, garnet's a very high density mineral, and it forms from, it's a calcium silicate mineral. This form of plagioclase is also made of calcium and aluminum and silica. And so at higher pressures, the plagioclase will react to form the garnet. And so this rock actually was buried deep. It grew these garnets. We can, in some places, the garnets are much better preserved than here. And we can analyze the chemical composition of the garnets and the coexisting plagioclase and the hornblende with that. And that's a very sensitive record of the temperatures and the pressures that the rock reached. Here we have results up to nearly 800 degrees Celsius and 10 kilobars of pressure. What's that mean? 800 degrees Celsius is extremely hot. 10 kilobars of pressure would correlate to about 35 kilometers depth in the earth. As these rocks were brought back up then, the garnet reacted back to plagioclase, and as the rocks were stretched, you see this stretching lineation. The original round splotches were stretched into these long shapes that, if the rock were in place, would line up with the same stretching direction that we saw in our mylonites up higher in the gorge.